Hello everyone, my name is Mehnaz. Welcome to Blockchain Primer with me. When I started learning blockchain almost a year ago, I realized that it's quite hard to get one's head around it. So I put together this course for the people who are new to blockchain in a very concise but comprehensive manner. So this course will take you through the fundamentals of blockchain, both technical and non-technical. At the end of the course, I request each one of you to provide the feedback so that I can improvise it for the rest of the students. Thank you so much for your time and happy learning. Let's have a look of what we're going to learn in this course. We are going to learn about why do we need the blockchain. So even before we delve into the technicalities of the blockchain, we need to understand why we need it. What is it that the technology of today cannot solve and how blockchain will help you solve it? Next, we are going to learn the difference between the blockchain and DLT because it can be confusing in the beginning. After that, we are going to learn about the core concepts of blockchain, things like immutability, decentralization, and more. After that, we are going to learn about the technical concepts of blockchain. So how the concept of immutability and decentralization are achieved technically. We are going to learn about things like consensus algorithms, hashing, mining, and more. Next, we learn about the types of blockchain. After that, we are going to learn some interesting terminology that fly around in the blockchain space. Things like ICO, that is initial coin offerings, DeFi, that is decentralized finance, 51% attack, and more. After that, we are going to learn how blockchain is being currently used around the world to solve different real-time problems, and also in which direction blockchain probably move. Towards the end of the course, I'm going to share a few resources with you which will help you to get started with blockchain. So let's go ahead. Alright, the first topic is why do we need the blockchain? There are many factors and reasons of why we need it. We're going to discuss only few of them. Specifically, TCP/IP protocol requires overhaul because we need better collaboration. Because data is centralized, there is lack of transparency and middlemen in every system. So we are going to discuss about each one of them and see some videos which will help us explain more about them.
The early internet was quite simple with very few nodes connected to each other. It was used for most very basic communication. In 1989, Sir Tim Berners-Lee developed World Wide Web on HTTP protocol. This made it easy for the nodes to access other nodes in the network, and sharing of the information became widespread. As the internet evolved, it gave birth to centralized systems that we see today. The commercialization of the internet led to the loss of transparency, privacy, security, and monopolized the internet.
Alright, so as the internet gained momentum, people started commercializing it. So all the expanding systems of today that we have, like the social networking websites, the financial institutes, the car and the bike rental websites, or even the shared economy websites like Airbnb are based on TCP/IP protocol. TCP/IP protocol lays the foundation of these systems. But the problem is these are the centralized systems, and it's the centralized systems that set the rules for privacy, security, data usage, and everything else. So TCP/IP protocol requires an overhaul so that the rules of security, privacy, data usage policies are not set by these centralized systems, but are instead built into the technological foundation of these systems. And users like you and me who actually use the systems have the possibility to set these rules. Maybe something like this. So TCP/IP protocol requires a layer on top of it that can lay a foundation to build the systems of the future.
The world is hyper-connected. There is cross-country flow of goods, even the production of goods is scattered over multiple countries. There are product designers in one country, product creators in another country, and customers in yet another country altogether. Likewise, when we transfer money from one country to another, there are several parties involved, and each work with different and incompatible systems. Blockchain will lay a foundation for developing systems with better and inherent collaboration capacity and data security. This leads to data integrity, data compatibility and more trust among the collaborators. Everything we use internet for, there is data generated. Data is in the form of our personal details, photographs, money transactions, social life, doctor appointments, purchases and everything else. All this data is stored in central servers of some organizations, which is used for their personal gains. We have absolutely no control of where our data lands. And who controls it. With blockchain, there is no central authority, who owns, or controls the data. Blockchain works on peer-to-peer system. No one system is superior to other.
All right, so far we looked at three factors of why we need the blockchain. We saw that we need blockchain because TCP/IP protocol requires an overhaul. We need better collaboration because data is centralized. We now are going to have a look at two more factors of why we need the blockchain. No transparency in the existing systems. Now, the existing systems lack transparency because either the systems are centralized or the system that's used by collaborators are not compatible. There is no way to know how the data has been changed over a period of time and who changed it. Banks lack transparency and so does supply chain. So there is a need for a system in place where the data is transparent. This will prevent the misuse and exploitation of data. Blockchain solves this problem by having the same immutable data available to all the participants of the network. Middlemen in every system. Well, we all know this. Most of the transactions we make on the internet are charged because of the middlemen. All the financial and non-financial institutes thrive because they take a small cut of our money. Take an Airbnb transaction, it's charged at 3% as of now. The flight bookings, bus bookings, and even the booking of a movie tickets are charged because we make transactions on a third-party system. Well, blockchain is set to change this by achieving a near zero transaction fees. Alright, so if you put all these factors together, we can summarize that we need blockchain because blockchain allows for a better orchestration between multiple organizations or systems, bringing in better data security, better data integrity, compatibility, and trust among the collaborators. All right, so far we learned about why do we need the blockchain. Let's move on to the next topic, and it's about the difference between the blockchain and DLT, that is distributed ledger technologies. To understand the difference between the two, we first need to understand very briefly what is blockchain. Let's see this video.
Blockchain stores records in the form of blocks. Each block contains a bunch of transactions. These blocks are time-stamped, arranged chronologically, and linked to each other cryptographically. This chain of blocks is a database, or ledger, which is stored in multiple computers, or nodes, around the world. This makes a blockchain, a decentralized and distributed ledger. Because the blocks are linked cryptographically, it makes them, and the records inside them immutable. A transaction in a block can be transfer of money from person A to person B, transfer of any asset, a record that a product has been packaged and shipped by a partner in supply chain, or anything that needs to be recorded.
The previous video explained about blockchain in a very concise manner. So DLT has been into existence for quite some time now. The confusion between the blockchain and DLT arises because blockchain is a subset of DLT. Or in other words, blockchain is a type of DLT. So they share the similarities but have their differences too. As you can see on the screen, both of them are distributed, both have consensus algorithms, both are peer-to-peer. The difference between the two lies in the concept of blocks. In blockchain systems, the transactions are packaged in the form of blocks, and these blocks are then linked cryptographically. But in DLT, there is no concept of blocks. One of the very good examples of a system which is more of a DLT and it's not really a blockchain is R3 Cora. In R3 system, as the transactions come inside the system, they are verified by the nodes of the network. And once all the nodes or participants of the network reach consensus, the transactions are then made part of the database or the ledger. All right, the next topic is core concepts of blockchain. We are going to discuss about the 5 core concepts of blockchain. They are decentralized, distributed, consensus, immutable, and trustable. So let's go ahead. Let's learn about the first 2 core concepts of blockchain, decentralized and distributed. We have already seen 2 videos which talk about the decentralized and distributed nature of blockchain. Let's learn a bit more about them. The nodes of a blockchain network represent a person or organization who form the network. Blockchain is said to be decentralized because the data inside the blockchain network is not controlled by a single node or an entity. Likewise, the rules of privacy, security, or even data access is not controlled by a single node or an entity. Blockchain network works on peer-to-peer protocol, which means that no one node has an authority over the other. So in blockchain systems, there is no monopoly like you have in the existing systems. And because the database or the ledger is replicated around multiple nodes of the ledger network, blockchain is said to be distributed. The distributed nature of the blockchain makes it resilient to system failures. The next concept is consensus. The consensus in a blockchain network means that all the nodes or participants of a network agree upon the same state of ledger. And how does it happen? It happens because all the nodes or participants of a network need to follow the rules defined in the consensus algorithm. There are many different kinds of consensus algorithms. For example, Bitcoin blockchain works on proof of work algorithm, and Ethereum blockchain works on proof of stake algorithm. All right, let's go ahead with the next concept. It's immutability. Blockchain systems are said to be immutable because the transactions, once recorded inside the blockchain systems, cannot be changed, or they are impossible to be changed because of the way the blocks in a blockchain system are linked to each other. One has to expend a lot of time, energy, and money if one has to do so, and that's practically impossible. The immutable nature of blockchain systems makes it tamper-proof, which means it's a great technology to create the systems where one has to trace things. For example, where is your food coming from? The next concept is trustability. You might have come across many articles on the internet which talk about blockchain as a trustless system. Well, it's more like a misnomer because in blockchain, the trust is shifted from people to technology. In blockchain systems, people do not really trust each other, but they instead trust the system on which the applications are built, more like a technological trust. In blockchain systems, it's important to understand that trust is not because of one particular element. It's because of many of them put together. For example, the fact that they are peer-to-peer, they are distributed, they are decentralized, there are consensus algorithms in place. All these factors together make blockchain a system which one can trust on. Alright, so far we learned about why do we need a blockchain, the difference between the blockchain and DLT. We also learned about the core concepts of blockchain. Let's now move on to the next topic, the technical concepts of blockchain. Alright, the next topic is the technical concepts of blockchain. Blockchain is quite a technically deep topic, so we are just going to learn about the core technical concepts of blockchain, specifically about peer-to-peer protocol, cryptography, hashing, merkle trees, fork, consensus algorithms, and mining. So let's go ahead. The first one is peer-to-peer protocol. As I discussed earlier, the nodes of a blockchain network work on peer-to-peer protocols. It just means that if my computer needs to communicate to your computer, it will do so directly without having the need of third party to facilitate the communication. The nodes of a blockchain network also work on peer-to-peer basis. The second is cryptography. Cryptography is used in computer science when one has to hide some information from intruders. There are many different kinds of cryptographic algorithms like RSA, Blowfish, and ECC. ECC means elliptical curve cryptography, and it's this cryptographic algorithm that's used inside the Bitcoin blockchain. The next concept is hashing. Hashing is just a mathematical function that is used inside the cryptographic algorithms to convert the data to something that cannot be understood. This unreadable data is called as a digest or hash. The next concept is merkle trees. So merkle trees is just a data structure that is used inside the blockchain systems to store the transaction inside the block. And the reason blockchain systems use merkle trees as their data structure is because this data structure is quite efficient when it comes to verifying the existence of a transaction inside a block. All right, the next concept is consensus algorithms. Consensus algorithm is nothing but a set of rules or protocols which all the nodes of the network need to follow in order to reach the same state of the ledger. There are many different kinds of consensus algorithms. For example, we have POS, that is proof of stake. We have POW, that is proof of work. We have PBFT, that's practical Byzantine fault tolerance, and many, many more. One interesting thing to note about the consensus algorithm is that you can plug and play them in your blockchain. For example, the only algorithm that works with the Bitcoin blockchain is proof of work, whereas in case of Hyperledger blockchain, you can choose from many of them. You can choose from Kafka, Raft, PBFT, and many more. The next concept is fork. In blockchain, we have three different kinds of forks. We have the temporary fork, hard fork, and soft fork, and all of them are related to the consensus algorithm. So as I said, consensus is a property of a blockchain when all the nodes of a network agree upon the same state of the ledger. Consensus is an emergent property of a blockchain, which means that it takes time to reach the consensus, which in turn means there might be a temporary state when not all the nodes of the network are in consensus. This temporary state, when not all the nodes of a network are in consensus, is called as a temporary fork, and they are resolved quite quickly. The other two kinds of forks, soft fork and hard fork. Just like we have updates in the software, likewise we have updates to a consensus algorithm as well. So whenever there are updates to the consensus algorithms, all the nodes of the network need to update themselves. Soft fork occurs when the nodes who do not update to the latest version of consensus algorithm are still able to create a transaction or mine a block. In other words, soft forks are backward compatible. Hard fork occurs when the nodes who do not update to the latest version of a consensus algorithm are not able to create a transaction or mine a block. In other words, hard forks are backward compatible. The next concept is mining. The process of finding a right hash of a block is called as a mining. Mining is a term which is very specific to a Bitcoin blockchain. In case of Ethereum blockchain, for the similar process of creating a right hash for a block, we call forging. So forging and mining are the similar terms, and they refer to process of creating a right hash for a block. All right, so that was quite a lot of theory to understand all the concepts, technical and non-technical, that we have learned so far. Let's learn a bit more about them. So we are going to take an example of land titles in India. Land ownership in India is primarily established through a registered sales deed. However, the data is not maintained and updated regularly, leading to discrepancies in the system. It's the responsibility of the buyer to check the past ownership, which in itself is a nightmare. Besides, the cost of registering a property is so high that many people don't even register their properties. Moreover, there is a separate data that is maintained at city, state, and village level, leading to more discrepancies. We are going to assume that we have a hypothetical solution for this problem, and it's called as a recurrent blockchain solution. And we're also going to assume that it works with proof of work algorithm. So let's see some videos which will help us explain all the concepts that we have learned so far. Let's go ahead.
Recland is a hypothetical blockchain network of nodes, or computers, formed by the network of people who own a parcel of land. As more people join, the network grows. No one node has authority over the other. It works on peer-to-peer basis. Let's start with a small blockchain, consisting of 10 nodes, or computers. All these nodes run Recland blockchain protocol on their computers, in order to be part of the network. Let's say, Stanley owns a parcel of land, and wants to register it. First, he has to join the blockchain network. He then creates a transaction that, the land belongs to him. This transaction is broadcasted to all the peers that his node is connected to. Each of his peers verifies and broadcasts the transaction to their peers. Verification is based on certain rules of the blockchain protocol. This continues till all the nodes receive the transaction. Just like Stanley, there will be many others in the network, who would like to register their land and create transactions in the similar way. Any change of ownership of a land, will also be registered as a transaction, and verified according to certain rules. A subset of nodes called miners, have a special function to perform. Miners package a bunch of the verified transaction, into a logical block, based on certain criteria. Miners then try to mine a block, by generating a hash for the block. A block is said to be mined, if the hash generated is less than some target value. To summarize, mining is to generate the right hash for a block. Proof of work is the energy expended by a miner to generate that hash. The block, mined by a miner in the previous step, is broadcasted to the peers. The peers verify the block received, and propagate it. This continues till all the nodes of the network receive a verified block. All the nodes then update their local copy of their blockchain. The blockchain network is then said to have reached consensus. Sometimes, two miners mine a block at the same time. Both these blocks propagate the network. This results in the nodes having different copies of the blockchain. When a blockchain is split into more than one version, it is called fork. A node has a local copy of blockchain, and has view of the network as well. When a new block is mined, and propagated in the network, nodes update their local copy. As this node updates its local copy, it checks the longest chain in the network. The network has accepted blue, yellow, purple as the longest chain, which means more energy has been expended to create it. The node is forced to review its local copy, and accept the longest chain as the right chain. That's how the forks are resolved, and consensus is achieved. A block has two parts, head and body. As we learned earlier, transactions are stored in the body. But the transactions are first hashed, and then stored in the block. Hashing is a method in cryptography to convert data, of arbitrary size, to a fixed length string. There are many algorithms for this. One of the commonly used is secure hashing algorithm 256. As the output is always 256 characters long, irrespective of the input. Each transaction in a block is double hashed, that is, it's hashed twice. And, stored as Merkle trees. Let's say there are 4 transactions. Each transaction is hashed. Hashes are paired, to create new hash, until we have just one hash. This hash is called as root hash, or Merkle root. And the tree that is formed is Merkle tree. So, block head contains Merkle root, and the block body contains Merkle tree. Transactions are hashed and stored as merkle tree in a block. Merkle root is stored in the header. Merkle root, along with other data in the header, is hashed to create hash of the block. This block hash is stored in the header of the next block. So, each block contains hash of previous block, linking them cryptographically, and thus, making a chain.
Alright, so that was quite a simplified version of a blockchain solution, but I hope it made the things clearer to you. I would like to talk a bit more on mining. So as the miners mine a block, they are incentivized. The incentive mechanism of a blockchain is what keeps blockchain safe. As long as the majority of the miners are not rogue, blockchain is safe to use. So let's look at the benefits of applying this blockchain solution to land titles in India. No multiple records need to be maintained at the city, state, and the village level. This makes the system way more efficient. As the data is available to everyone, there is no room for discrepancies. And as the data is immutable, history of any piece of land can be tracked back. Alright, the next topic is the consensus algorithms. There are many different kinds of consensus algorithms, as I already discussed about this. We are going to learn about three of them: proof of work, proof of stake, and proof of elapsed time. If you would like to create your own blockchain, you might want to choose from any one of those existing in the market and based on your needs. So let's go ahead. Alright, the first algorithm that we're going to learn about is proof of work algorithm. We have already seen some videos which talk about the proof of work algorithm, so I'm just going to summarize it. Nodes first create a transaction and broadcast it to the peers. The nodes of the network then verify this transaction individually. Miners take a bunch of these valid transactions and put them into logical blocks. The miners then find the right hash for this block by changing a parameter called nonce. Once the right hash of a block is found, it is propagated into the network. Each node in a block in the network then verifies this block. Once verified, this block is integrated into the database or the ledger, and all the nodes agree upon the same state of the ledger by following the longest chain. Alright, so let's now learn about the two more algorithms, proof of stake and POET, that's proof of elapsed time.
To become candidates in order to validate a new block, nodes keep some amount cryptocurrency at stake. From the pool of these candidates, a selection algorithm chooses a node. It combines the quantity of stake with some other factors to make the selection process fair. In proof of stake algorithm, blocks are said to be forged, unlike proof of work algorithm, where blocks are said to be mined. Once a new block is forged, a validator earns a fee from it. This algorithm works in combination with SGX, that is, software, guard, extension, technology of Intel, and involves three steps. Step 1, a node needs to install SGX. This ensures that the node is running trusted code, which cannot be manipulated. Step 2, the node then propagates join message to the network. Once it is accepted by the other nodes, the node can become a candidate for validating a block. Step 3, network participants, running the trusted code, receive a signed timer object from the trusted code. This process is completely randomized. Subsequently, each participant waits for the timer to expire. The participant whose timer expires first becomes the leader and creates a block.
Okay, so before moving ahead, let's try to see what we have learned so far. We learn about why do we need the blockchain. We learned the difference between the blockchain and DLT. We learned about the core concepts of blockchain. Next, we learned about the technical concepts of blockchain. And now we are going to learn about the types of blockchain. Let's go ahead. So we have three different types of blockchains based on who has the access to the network. We have the public blockchains, private, and hybrid. The first type of blockchain is public blockchain. These are the blockchains which are decentralized in a true sense. In public blockchains, the access is wide open. There are absolutely no restrictions as to who can join the network. Anyone can become a node or a miner and participate in the blockchain. There are absolutely no access right controlled by anyone. Two good examples of a public blockchain are Bitcoin and Ethereum. The next type of blockchain is a private blockchain. These blockchains are owned by an organization. The access is limited to specific users, and the access right is given by the administrator of the organization. The users of this blockchain may have different rights decided by the organization. So only some nodes may be involved in the consensus, others may be involved only in the mining. Anyone outside of the private network cannot see or participate in this blockchain. One example is Hyperledger. Because the number of the nodes in the private blockchain are much lesser compared to the public blockchains, these type of blockchains are much faster than the public ones. The third type of blockchain is a hybrid blockchain, also called as consortium blockchain. These are controlled by a group of companies forming the consortium, for example, a group of banks. In the process of consensus, only specific nodes are involved, and these specific nodes are the ones which are determined by a group of companies forming the network. Two good examples of a hybrid blockchain are Ripple and Facebook Libra. Let's now move on to the next topic, some interesting terminologies that fly around in the blockchain space. We are going to learn about cryptocurrencies, double spend, 51% attack, smart contracts, DApp and DeFi. Let's go ahead. Let's learn about the cryptocurrencies. In the olden days, we had gold as a medium of exchange, and then came the fiat currency. We now have a new type of currency that is digital based and is called as the cryptocurrencies that can also be used as a medium of exchange. There are different types of cryptocurrencies like Bitcoin, Ether, IOTA, and many, many more. For the beginners, it's difficult to understand the difference between Bitcoin and blockchain. Bitcoin is just a cryptocurrency, and blockchain is a technology that underpins all the cryptocurrencies, including Bitcoin. So if you are an Xbox fan, you can use Bitcoin to make a purchase from Microsoft. Also, if you are in Canada and a KFC fan, you can use Bitcoin to make a purchase from them. Ether is another type of cryptocurrency that works with Ethereum blockchain. The next is double spending. All the digital properties, including the images, videos, or the messages, can be copied and used multiple number of times. So digital cryptocurrency is also a digital property. It can also be copied and used multiple number of times. When someone does this, someone uses a cryptocurrency more than once, we call as a double spending. Now you really don't have to worry about this because all the cryptocurrencies take care of the double spending technically. The last one is 51% attack. When we say that the blockchain is a decentralized network, it means everything inside the network is decentralized. No one node or a group of nodes can combine together and use the network for their own benefit. The data, the authority to set the rules, or even the mining power that's required to create a block inside the network are decentralized. Now the power to create a block, to mine a block, is called the hash rate, which is also decentralized. but it may happen that the hash rate is controlled by more than 50% of the rogue miners, and they use it against the whole system. Now, 51% attack can cause many problems, like they can cause a double spending. They can even prevent the transactions from getting verified. Let's learn about smart contract. A smart contract enables a transaction to take place without the need for a third party, unlike a traditional contract. Smart contract contains all the rules that need to be enforced before a transaction can take place. For example, if I need to transfer my home to you, I can sign a smart contract with you. This smart contract will be deployed on a blockchain network. Once all the conditions defined in the contract are met, like I receive all the documents from you, I get the agreed upon amount from you, a smart contract will be executed automatically, and the transfer of ownership from me to you will be visible to all the nodes of the network. Next, we have the DApp. DApp is derived from a decentralized application. It's just like a DApp is just like a normal application, but it's based on decentralized platforms. Just like a regular application is made up of features, a DApp also contains features and smart contracts. I can say that a smart contract is a part of a DApp. For example, a Steemit is a social networking DApp, and Atlance is a job market platform built using the blockchain platform. Next we have is DeFi. DeFi is a blanket term that's used for all the financial services like lending, borrowing, trading, investing, and everything else built using a decentralized platform. DeFi does not does not depend on a third party for any of the services. Like it does not depend on a banks for any of these services. All right, the next topic is use cases of blockchain. So before we go ahead and look into different use cases of blockchain, it's important to understand that blockchain is not a new technology. Rather, it's the multiple existing technologies that have been put together in a novel way. Having said that, blockchain is not a magic wand that can be applicable to all the existing problems. The best use case of blockchain is when there are multiple parties and blockchain brings them together, providing value for each one of them. We are going to look into three different use cases. For social media, we're going to look into Steam. For agriculture, we're going to look into Indian Coffee Board. In the healthcare, we're going to look into Mediblock. So let's go ahead. All right, the first use case that we are going to look into is Steam. All of us spend a lot of our time creating content for different social media platforms, but we don't really get paid for it organically. Steam is a blockchain-based platform which pays you for two things. The first one is number of upvotes the content that you create gets, and second, it's for the interactions that you make with the content on it. This blockchain-based platform pays you in the form of cryptocurrency called as Steemit, which is native to this platform. It's quite a growing community, though yet to beat any of the existing social media platforms. So keep an eye on this one. All right, the next use case of blockchain that we are going to discuss is related to agriculture. The Coffee Board of India has developed a DApp or decentralized app in order to improve the coffee trade in India. The benefits of using this DApp are it removes any intermediaries, allowing the farmers to get a fair price for the produce. It brings in transparency in the trade of coffee by allowing the farmers to market their products directly to the customers. It even lets the consumers to track a cup of coffee they have on the table. Now, your coffee might not taste better, but for sure it'll bring in peace knowing the source of the coffee. All right, the next use case of blockchain that we're going to discuss is related to healthcare. There's a massive amount of data generated in the healthcare sector. The data is generated from patients, doctors, pharmacies, clinical trials, research, and many more sources. But all this data is siloed, or in simple terms, all this data is isolated from each other. Mediblock blockchain brings in all this data together with the highest degree of security and integrity to build the systems that can create better healthcare products. It's a public blockchain, and the miners or forgers are generally the block creators are incentivized with a cryptocurrency called as MED. This cryptocurrency can then be redeemed inside the MediBlock ecosystem. Quite an improvement in the way the data is handled in the medical sector. All right, the last topic that we're going to discuss in this course is blockchain standardization. As I already mentioned, that blockchain is a novel use of multiple existing technologies put together. So it requires standardization like any other industry. We all know that TCP/IP protocol was standardized over a period of time, and so was HTTP protocol. Blockchain will also go through the same phase of standardization. We all know that there are multiple blockchains in the market. We have the Bitcoin blockchain, we have the Ethereum blockchain, we have Hyperledger, R3 Cora, Quorum, and many new ones are being created. So there is definitely a need for creating, standardizing things like how to build in privacy, how to build in security, and even interoperability between multiple blockchains. So ISO, that is International Standard Organization, has come up with a technical committee to standardize blockchain. The work of standardization has already begun, and some of the areas where the work is being done is security, identity, smart contracts, governance, and interoperability. Blockchain industry as of now is fragmented and it's addressing a diverse range of problems. So standardizing things will bring in more innovation and its increased adoption. All right, so this brings us to the end of the blockchain primer, but it starts your journey to learn a vast topic of blockchain. If you're really interested to learn further, you must consider learning cryptography and distributed computing. You must also look into the architecture of Bitcoin blockchain and see how it's coded because that's the first public blockchain solution. You can refer the book Mastering Bitcoin by Andreas Antonopoulos. There are many other online resources that can help you get started, like hyperledger.org and ethereum.org. So thank you so much for your time, and I hope this course really helped you. I request all of you to provide the feedback so that I can improvise the course for the rest of the students. Thank you once again and happy learning.